right now on Teams. Let me show you. On Teams, right? So saying, how are we doing with the VM? Because we did get a lot of responses from you. So thank you very much for taking the time to respond to us, but we didn't get the responses from everyone. So that's why we're asking, are you okay with the VM? Yes or no? And if we get some thumbs downs, that will make sure to address those issues or demo how to import the VM and everything. So please do vote on those polls. It's really going to make it a lot easier for us, especially when we get to labs and some hands-on sessions. Okay, yeah, thank you very much. I can see all the thumbs ups occurring there. Awesome, thank you. All right, yeah, so the virtual machine has some credentials. I'll show you everything later on. Sometimes we do get people turning up with like iPads and netbooks. I don't know if you remember netbooks, but yeah, netbooks were awesome. Like a really cheap device, 10-inch screen, single core Atom processor, and it couldn't run anything, let alone a virtual machine with like Kubernetes in it. And so yeah, that might not be the ideal choice for this training. There are some hardware requirements for you to comfortably be running the virtual machine, but unless you're running this on like a really cheap device, you should be okay. You can probably watch this on an iPad, like the Zoom session, I mean, but yeah, an iPad probably isn't the best platform for virtual machines. So just again, we've gotten a lot of responses from you saying VM is fine. So just wanted to point that out. And finally, we've got the schedule. So the Black Hat trainings run from 9 a.m. to 6 p.m. We should not be in a position to run over that. We are going to be taking some breaks during the session as well, obviously to eat lunch and just get a break from everything. So the plan is actually I can switch to my slides for this. The plan is to have 2 coffee breaks throughout the day. So we're going to have a coffee break in about an hour, I think. Yeah, in about an hour. And we're going to have a lunch break around lunchtime. Yeah, you guessed it. And finally, we're going to have another coffee break in the afternoon. So yeah, we should all be able to get some rest from everything. Okay, yeah. So that's roughly the schedule. And there's one more thing I'd like to point out, and that is the it's kind of optional content here. It's the progress tracking portal, or like a CTF instance, essentially. I'm not sure we've got the link online just yet, but we will in due time. So I'm just going to show you this and talk over it as I'm showing you. All right. So last thing I'd like to show you before we begin is the CTFD instance we have running. So we're going to be doing a lot of labs. There's going to be a lot of hands-on exercises for us to go through. And most of these have a challenge associated with that lab. Not all of them, but where it makes sense, we have like a little challenge for you. So essentially, I'll always demo everything, and I'll give you some time to catch up. And I will not be demoing these like extra little steps that you can take, however. Right? So all these challenges that are mapped to the labs we will be going through. And I'll always show you the entire lab. But if you want to take like a couple extra steps, walk the extra mile, you can do that. A lot of these challenges essentially have some extra little task for you to look into, you can follow up on that if you choose to. This is completely optional. You don't have to do this if you don't want to. Some people are very competitive. Some people are not. That's fine. We usually get a lot of competition going on, you can show off your lead skills. Lots of these challenges essentially give you points, once we get to some hands-on challenges, we'll be able to track how you guys are doing, and who's the quickest to solve a challenge, and so on. So it should be fun, but yeah, as I say, completely optional. You don't have to worry about it if you don't want to do that. If you just like to listen and watch demos, that's completely fine. We all learn in different ways. And most importantly, we're not in school. I'm not going to force you to do anything. So completely up to you. I think Manish has very kindly posted a link on Teams, and in due time, I think we're also going to add the link to the MD books. Maybe, I think. Yeah, it's already there. Yeah, cool. Yeah, so you can also find the link to this website on the training portal. The credentials you have been provided with, they fit everything from AWS through this portal, through CTFD. Like everything is the same credentials. So you should already have the credentials. Okay, cool. So that's the sort of organizational side of things. So, okay, we should be good. We should be good. Okay, so I think we can move on. And I'd like to talk a little bit about cloud because we typically get a mixed audience. Not everyone is a cloud engineer. So I'd like to give a brief intro into cloud. I know from your credentials, a lot of you are familiar with cloud already, so I'm just going to go quickly through this section. I would just like to mention a couple of terms, mention a couple of concepts, make sure that we all have at least a rough idea of what we're going to be talking about throughout today and the subsequent days of the training. I'm also going to stop the webcam because it's getting really distracting, looking at my face all the time. I'm too distracting. I'm too beautiful. I need to turn this off. Okay, here we go. All right. So cloud. So what is cloud? Yeah, that's kind of a big question. The main thing I'd like to sort of dispel here is a lot of some people that can have some cynical remarks regarding cloud, saying it's literally just someone else's hardware. There's nothing special about it. But there's quite a lot of extra functionality on top of that, right? So it's not, technically speaking, untrue. It is someone else's hardware that you're renting, but there's a lot of extra functionality that comes with all of that. It's quite, all the offerings and all the services in cloud are typically very, very highly interconnected. So there's a lot of extra value you get from it. If you think back, like 2 years back to the start of the pandemic, when everyone was told to stay at home and just remotely connect to your company VPN or to connect to your intranet, a lot of companies had VPN aggregates already, but they may not have been designed to handle 100% of your workforce connecting from home, right? That was never intended. And it can be a bit difficult to quickly buy a hardware appliance or like an aggregate somewhere and go and install it to a data center when you're told by the government to stay put, to stay at home. In cloud, however, you can essentially click a few buttons. I'm simplifying it, but you can click a few buttons and suddenly you have extra capacity available. So cloud is really cool in a lot of senses, and I feel like it's really pushed past that sort of hype wave, that sort of buzzword era. Because you get a lot of buzzwords, right? Like right now, the buzzwords are things like blockchain and crypto and all that jazz, smart contracts and NFTs, and there's a lot of buzz surrounding these terms. But I feel like cloud has really moved past that, and it really shows that it's here to stay. So if you were to break it down, mainly when we talk about cloud, we're talking about a big pool of resources that someone has bought and is essentially renting out to people so that you can use it whenever. When you're done with it, you can stop using it, stop paying for it. There's very little upfront cost. There are different types of cloud. To be completely correct on this, there are different types of cloud providers. We are only going to be talking about the public cloud side of things. So public cloud essentially means AWS, GCP, Azure, and a couple more of other providers. But it essentially means it's a public company, it's a public project that you can sign up to, subscribe, pay a monthly bill and use their offerings, as opposed to running things privately. So I don't know how things work in Singapore, for example, but here in the UK, it is quite common to mix those approaches. So we get kind of into like a hybrid cloud scenario where let's say a financial institution uses some cloud offerings for some public-facing infrastructure, but also they still need to have a data center, right? So they still maintain some on-premise infrastructure, and they try to essentially connect the two and reap the benefits of both, which is slightly challenging. There are some places that like to ride the hype wave of cloud. They say, oh, we've got a private cloud, which essentially means, you know, you have to buy all the hardware yourself. Not all of the hardware is always utilized, so it's not the best investment. And essentially, when something breaks down, you're out of luck. You need to replace that piece of hardware, as opposed to doing things in public cloud, for example. Okay, so if that wasn't complex enough, we essentially have layers of some of the cloud offerings and some of the cloud services. You can treat this as kind of as a measure of how cloudy a particular offering is. Right, so starting from the bottom of the slide, we've got offerings that fall into the infrastructure as a service class. Right, so infrastructure as a service essentially means you are spinning up a virtual machine somewhere, and you have full access to it. And you know, anything that's on the VM, anything that has to do with the operating system, updates, deploying services, maintaining it, and so on, that all falls on you. You essentially get provided with a virtual machine, and that's it. So that's not very cloudy. We can definitely do better. So you can start moving up on this slide from bottom up. So you can start looking at containers, for example. And we will be looking at a lot of containers actually on day 3. We're essentially going to spend the entire day just looking at containers and orchestration services like Kubernetes, for example. So there's a lot of content to cover. It's going to take essentially an entire day, but more on that on day 3. Platform as a service offerings are sometimes very interesting. We're going to be doing an exercise fairly soon regarding the AWS Elastic Beanstalk offering and how it functions internally and how we can leverage that as attackers. But yeah, platform as a service usually tries to make it simpler for you, make it easier for you to deploy things. Say, if you are a developer and you have written an application in PHP, for example, and you don't know much about managing a system, you just need to have a place that runs PHP, right? So platform as a service can essentially provide you with an interface that's got a few buttons and a few select boxes, and you just say, I need like the latest version of PHP. I also need a Postgres database, click, 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 done. And magically, auto-magically, things get set up for you. And you just get to use that infrastructure and not sort of dwell on the details of, you know, do I use this instance or that instance and so on. So things are a bit easier on you. There's a lot of automation behind the scenes, which kind of means you give up a degree of control. And as we keep going up on this slide, as we keep going up towards serverless or function as a service offerings, that effect is amplified. So with function as a service offerings like Lambda, Cloud Functions, so GCP Cloud Functions, Azure Functions, and so on, you are essentially in a position where you literally just write code. You just write a bit of code in, I don't want to say any language. There are some limitations, but for the most part, any kind of popular language that you choose. And you literally just deploy the code into cloud, map it to, for example, an API endpoint, and you're good, right? You don't have to worry about things like scaling and providing a lot of infrastructure beforehand. So I can really simplify things for you again, because you just get to focus on the code side of things not on the maintenance and infrastructure and planning ahead side of things. And if you take it to the extreme, you can essentially look at software as a service. And at that point, you're essentially just paying a subscription fee for a service online, like Salesforce or O365 or something similar, right? Essentially, just paying a monthly fee, you get a service provided to you. You do not worry about anything regarding the infrastructure this runs on. How is it going to scale in and out? None of that is your problem, which is very liberating, especially for sysadmins. Because when that 3 a.m. call comes in saying website's down, you can, to a certain degree, say, no, it's not my problem. It's the problem of someone else. So yeah, that's why we like cloud, because we get to shift your responsibilities away onto someone else. Right. So this is probably the most controversial slide I have. That's mainly because there's a pineapple on this pizza slice. Yeah, I know, it's a horrible joke. Forgive me. I do it every time. I know it's a horrible joke, and I still make it every time. I'm a bad human. Yeah, sometimes we get interesting responses to this, interesting reactions. Like we get people saying, "There's nothing wrong with that. I like strawberry on my pizza," which is an odd choice. That's probably the oddest choice. Strawberries on pizza. I don't even know how that works. But some people like it. I hope I have not offended any one of you. Maybe one of you likes strawberry on pizza. If you do, let me know how that works. But yeah, essentially, what this slide is trying to do is kind of lightheartedly look at the responsibilities that you have as a cloud subscriber versus what the cloud provider has to do for you and what is their responsibility. All right, so if we compare that entire something as a service to throwing a party, for example, at the left-hand side here, your sort of traditional setup where you do everything yourself. If you were to do that, if you wanted to have a party, if you wanted to invite people over, have something to drink, make some pizzas, you can do that, but you're going to have to do all of that yourself. Right? We're dealing with an on-premise scenario. Like you have to build the data center, buy the hardware, hire people and security and maintenance and so on. There's a lot of tasks and a lot of maintenance as well. And you can absolutely do that, but it comes with a lot of drawbacks and a lot of possible headaches that you can avoid should you leverage even the basic cloud offerings like infrastructure as a service here. We can kind of compare that to like a communal kitchen, right? If I want to have a party, I want to invite people over, we want to have some pizza, we want to have some drinks. If I'm making all of that, that's going to be a logistical nightmare for me. And I know that from like first-hand experience because I quite like to bake pizza. So I've got like a sourdough starter on my kitchen counter. And I know if I want to have a nice pizza base, I need to make the dough like 3 days in advance and let it ferment slowly. And there's a lot of planning involved and a lot of things that really easily can go wrong. So if you start to leverage something as a service offering, even the lowest level, right, just infrastructure as a service offerings, already some of these tasks are delegated to your provider and you don't have to worry about them, right? So in this instance, that would be like a communal kitchen that has multiple ovens, and maybe the ovens go a little bit higher in temperature. So for some things that's really beneficial. They've also probably got more than one oven. And if you try to make a lot of pizzas in one oven, it's not going to go very well. But at the same time, you don't want to have 5 ovens in your kitchen, right? Ideally, you'd use something like this for peak times to easily scale out with some of the infrastructure. And you can essentially keep taking this to the extreme where at the most right-hand side here, software as a service, you're essentially like delegating the party to someone else. You're just kind of showing up. You just show up to someone else's party. Right? And that ticks all the boxes. You know, they're probably going to have some pizza, they're going to have some beer, they're going to have some people over that you can talk to. You just ticked all the boxes with very little effort. You literally just turned up. So you can be quite lazy in the sense of what is your problem, what is your responsibility versus responsibilities of someone else. Okay, so this is a slightly more formal look at what we've just seen. So less pineapples and less pizza, more tables, more matrices. So yeah, essentially, I always feel like I'm doing a sales pitch. I am not. I'm not affiliated, and we're not affiliated with any of the cloud vendors. So no, I'm not doing a sales pitch. I'm just giving you an idea here of some of the benefits of cloud and why even talk about cloud really. When you look at the difference between doing things on premise versus going in cloud, even for the most minimal offerings, suddenly you can draw a line here, and all of this is now someone else's problem, right? It's someone else's data center that you're using. So things like physical security and making sure servers keep running, and if a hard drive fails, how do you replace it? All of that is completely transparent, and you don't have to deal with it. So that's the main point really. And as you can keep taking this further to the extreme where you really don't have to deal with much. If you look at, for example, software as a service, we can see that we don't have to deal with much. We've got the client side of whatever application we're using, but mainly we've got the data and the access controls surrounding that data. Those two things you have to deal with yourself. Like no one else can really do that for you. But everything else like is just being taken care of by someone else, and you don't have to worry about it. So yeah, that's just the point I was trying to get across. That yeah, some of these services essentially take a lot of responsibility off your shoulders, and they make it someone else's problem. So yeah, I think I may have missed a question. I think someone's unmuted. If you have a question, feel free to ask. Sorry, please go ahead. Okay, sorry. Okay, it might have been an accidental unmute. No worries. Sorry, I thought I was talking over you. My apologies. Okay, so that's cloud. That's the sales pitch over. Now let's look at the security side of things. I just wanted to give you like a quick rundown of what happens in cloud and how things work, so that, you know, even if someone's brand new to this, they'll have a rough idea of what we're doing. Okay, so looking at the security side of things. So even now in 2022, there's still a pretty major push by a lot of organizations and a lot of places to be cloud native, or at least aim at being cloud native. We've seen a lot of the benefits about that on the previous section, but there are also some negative things. And those are the things that interest us, security people, right? Because that's what we need to make sure is secured, or that's something we can exploit to gain foothold in someone else's environment. Because cloud is such a paradigm shift, as we'll see in a second, there are a lot of assumptions that you can fairly safely make on premise, but not in the cloud. And we're going to be essentially relying on that for a little bit as well. Cloud also brings extra attack surface forward. You've got things like cryptojacking. Essentially means that someone else is mining cryptocurrencies in cloud whilst you're footing the bill. And we'll talk about how that works and how to protect against it as well. I just wanted to give you a quick example. Or a very destructive attack, which can essentially take a company, just end the company in the most extreme case. We'll also take a look at that. We'll take a look at a company that got hacked, everything got removed and they couldn't restore. And And we'll talk a little bit more about that, but I'll save that for later. The main thing I'm trying to get across is cloud is very interesting, it's very beneficial, but also there is extra attack surface that we need to take into account. So to give you a quick comparison between things on-premise and things in cloud and how things change, one of the main things really is just seeking the approval, right? It's very simple to sign an agreement with a company saying, company A is going to do a pen test for company B. We're going to come in on those dates, and we're going to be targeting this one particular application, and we're going to write a report, and that's going to be it. But that's very simple if you own everything, right? If you have your own data center, if you have your own hardware, if you've written the application yourself, and you're just getting it tested, right? Because you don't really, it's all yours. There's no doubt about it. However, in cloud, obviously you are just a tenant. You're just renting things from a big data center along thousands of other customers. And you need to be a little bit careful about what you do as a pen tester so that you don't overstep the bounds of terms of services and just in general code of conduct. As I've mentioned, because cloud is quite a paradigm shift, there are a lot of things that used to be private on premise. Right? For example, if you take a typical infrastructure in a company on premise, right? You've got the cable from the internet provider coming in, and there's probably like a firewall or a NAT or a big router, essentially some security appliance that sits in front of everything, and everything else is behind this appliance. So usually you do not get direct access to every single appliance in your intranet, in your private network, because there's like this big firewall in front of everything. But that might not be the case in cloud. There isn't really a perimeter in cloud. You'll often hear that said as well, saying, in cloud, the internet is the perimeter. And that makes a lot of sense. I mean, when you spin up a new instance, let's say AWS EC2 instance, by default, it just gets assigned a public IPv4 address. That is not something that generally happens on premise, right? Typically on premise, your servers are separated from everything by a NAT or something similar, essentially meaning your servers are not directly exposed to the internet, but not the case in cloud, at least by default. And this is something that can surprise people because when you migrate things to cloud, sometimes what companies do is they just pack up what they have on premise, and they just pack it up, pick it up, upload it to the cloud, and deploy there. Right? So just pick up the VM you have, you upload it, and you deploy. But that VM was never meant to be publicly accessible, and suddenly it is. And that can lead to a lot of security issues. And we'll actually have some real-world examples of that. We're going to be looking at a couple of cases where that happened and what were the consequences, and mainly why did it happen. So we'll read through some case studies and try to figure out how to best guard against that. So if you're only getting into cloud, there's the thing that kind of did annoy me a little bit was that for things I already knew, there were like 3 other terms I needed to learn, just create a mental mapping essentially. And so on premise, you would typically say, I need a server, or like, where's the server, who owns the server, and so on. You're talking about a server, and everyone knows what you mean. But when you go to cloud, suddenly, AWS calls it EC2 instances, Azure calls it VMs, GCP calls it compute engines. So there's a lot of terminology you kind of need to learn and remember. So it's just so you're able to communicate with people about basic things, even though all of these are terms that you already know. But there's a very involved marketing team at each of these providers, and they are creative and come up with new things and new names for existing infrastructure and concepts. So that gets a little annoying, but nothing you can't deal with. But yeah, sometimes it is a little bit annoying. For example, when you look at the internal network here, if you have a networking background, you may already know VPC as an acronym for virtual private circuits. Essentially, in a non-switched network, it is a thing that exists, and suddenly you've got VPCs in cloud, but that means something else. So it can be a little bit difficult if you've never really dealt with cloud on this level to understand what people are talking about. But essentially, it's just all about creating a mapping between things you already know versus new things. I think the key takeaway from this slide would be probably the last row here, where we talk about domain admin and the quote-unquote mapping to a cloud terminology word. It is a little different, because obviously in cloud, you need to have an account that handles everything, right? You create an account, that account has a credit card, that account gets billed for everything, and also that account can see everything else. There's not really an equivalent of that on-premise. Probably the closest you can get is like a domain admin in a Windows network, right? Because that account can see everything and have interact with everything. But in cloud, it goes one step further. And we'll be dealing with that a lot. What happens when that account gets compromised, what it can lead to, how to prevent that as well. So yeah, I think the key takeaway from this slide is the sort of domain admin kind of doing air quotes right now, mapping to things like the root user in AWS or the super admin in GCP and so on. A couple more terms quickly for us to quickly run over. Again, I'm not going to read all of this to you. The main thing I would like to point out from this slide is that some attacks that exist on-premise and in internal networks and have existed for ages have kind of a cloud counterpart, but we call it something different because it is slightly different. So the thing I'm talking about is the pass the hash attack. Again, for the if you do deal with network security, you may have heard of this. Essentially, this is something that can happen in a Windows network. But if you compromise a set of credentials, maybe you don't fully compromise the credentials. Maybe you don't have the actual password of a user, but you have kind of a different variant of the password. You essentially have a password hash. And sometimes that's enough. Sometimes that's enough to use the credentials that you have somehow acquired and essentially do the pass the hash attack to essentially move in the network internally. There's a very similar thing in cloud, but in cloud, you rarely deal with passwords, right? You mainly deal with things like tokens. So to make it a little bit more accurate, you don't refer to this attack as pass the hash. You mainly refer to it as something like credential pivot, for example. And that's something we'll be looking into. That's something we're going to be looking into quite a lot. Essentially, exploiting a service, getting some credentials out of it, and moving laterally with those credentials that we have acquired. So yeah, credential pivoting, because you don't really deal with passwords and things like that. You mainly deal with like tokens and such. So yeah, just wanted to point out a couple of differences there. Okay, so I did say that cloud can be a little bit confusing as to the ownership of things. Pardon me, I've developed a little bit of a cough, sorry. Yeah, so again, I'm not a lawyer. I do not provide any legal advice, but there are some key differences here. As I've said, mainly it's about ownership of things. Right? If you are a bank and you have a data center and you want a pen test conducted, usually it's as simple as getting the pen testers to the data center, and that's it. It is quite easy to usually get approval. There's a process, but it's usually just that one party, that one bank that has to agree internally, as opposed to doing things in cloud. Now, this historically used to be a little bit of a friction point, but it's gotten much better. It's gotten so much more streamlined, and you shouldn't really run into issues these days, but it's still worth mentioning to just make sure you don't step outside of the allowed scope. So here we have a couple of examples of the pen testing guidelines and rules of engagement. Essentially, I believe Azure used to be like really annoying with this, where you had to really tell them about everything that you were going to do, and they would always tell you, yeah, that's fine. Essentially, if you had a client hosting things in Azure, you would have been required to talk to Azure and say, hey, you have a client that wants us to pen test their website, which means we're going to be doing some offensive security attacks or techniques we're going to be using against things that you host. Are you okay with this? And obviously they would be okay with that. After some time, I think Microsoft just got tired of saying yes or every time. So they just said, just do whatever. Be reasonable, but go ahead, do your job, it's fine. And that's a similar theme across all the cloud providers. I really like the kind of extra step that GCP did. Essentially, GCP tells you that, again, there are some sort of, common sense guidelines in terms of service, but mainly if you stray a little bit outside of this intended scope, or if you find something that is a problem, but it's not a problem on the customer part of the deal, it's actually a problem with our service itself, then if you tell us about it, we will not sue you, but rather we will give you money if you tell us. If you disclose to us that there's a problem with our service, we're not going to go after you, but rather we're going to reward you. And I think that's a really, speaking as a pen tester, this is really nice because that means, if I were to mess up and take 2 steps outside of the scope, even unintentionally, and find something, I can actually do some good, and I don't have to be too worried about being dragged through some legal process afterwards. So that's great. But let's now talk about AWS. So AWS essentially have a list of services that you can pretty much do whatever you'd like to, again, based on common sense and some guidelines, but mainly those offerings are fine. So things like EC2 instances, databases, API gateways, Lambda functions, and so on, they're quite okay with you doing pen testing activities against these deployments. However, they also list some things that they are not happy about. And a lot of this makes complete sense, and it's very understandable. For example, running a denial of service attacks or DDoS attacks against things hosted in AWS is kind of pointless, right? Because if you were to do that, then what have you really achieved? If you were to succeed and disrupt the network connectivity between you and the AWS resource, then what have you really achieved? Well, you've overloaded a network link in the data center, but that network link is being used by many, many other customers that are not okay with what you're doing. So you've not really achieved anything. You've just saturated a link that AWS has and annoyed a lot of other people, essentially impacted a lot of other customers. So that's not okay. So that's completely fine. That's completely understandable. You do not want to disrupt services for other people. However, then it goes to things like port flooding and request flooding. And depending on how strict you want to be with your definitions, port flooding essentially means you take a machine and you connect to it on many different ports. Again, hoping to achieve resource exhaustion condition, essentially a denial of service condition. That's pretty much what port flooding is. But it sounds very similar to a basic concept in network assessments, and that's a port scan. If I want to do a port scan against a machine, I'm going to open up a connection on every single port number from so essentially scanning 65,000 ports. And I would argue you need to do that as like a basic building block of a network assessment. But if you would be really strict on this, then the prohibited activities might kind of imply that you shouldn't be doing that. In reality, you're going to be completely fine as long as you are being reasonable in the sort of aggressiveness of your scans, and not doing the same scan, targeting the same machine over and over and over. You're most likely going to be completely fine, because again, that is something I would argue is necessary for pen testers to do their job properly. Right? Do a port scan is a basic thing to do, and I would argue a necessary element of any kind of assessment. But again, depending on how strict you are, could be in a gray area. But a more sort of worrying point is the request flooding side of things, and mainly the API request flooding and the, for example, brute forcing login as well. Again, as a pen tester, I feel like it's an important thing to check for. If you've got an application, is there any kind of rate limiting applied? Right? If I've got a login form and the login form, is brute forceable, it never gives me a captcha, it never tells me to go away. It gives out a lot of extra information that could help attackers. I'm actually going to be seeing an example of that in one of the upcoming exercises. So I would argue that this is a good thing to check for. Obviously, not to be running this case check for days on end, but it's probably a good thing to check for, mainly with the API requests. All right, so imagine that you have an API, and you've got some endpoints on this API, and some of them are quite costly. Right, you have an endpoint that if you hit that endpoint, it's going to do a lot of computation, and it's going to take like a second, maybe 2 seconds to come back to you with the results. And it might be doing a lot of really heavy computational operations internally. And if you're not careful, if you do not have rate limiting on that endpoint, then people might unintentionally take down your infrastructure or essentially cause a denial of service attack just by requesting that endpoint quite a lot, not knowing that it's so costly to you. So again, I would argue as a pen tester, to provide good value to our clients, I would be testing that as well. Now, I wouldn't be hammering the endpoint for days on end, but I would definitely test it. And if I would get rate limited, I would give a big thumbs up in the report. On the other hand, if it would get to a point where I can really slow the server down by issuing only a handful of requests to this expensive API, then that would be a problem. And I'm pretty sure that the client would like to hear about that. So again, I would argue this is required for pen testers to do their work. But again, everyone's moral compass is different. So it's worth pointing out that there are some kind of gray area bits and pieces that people might interpret differently. Okay, so moving on to moving upwards, really. Moving upwards, taking a look at the entire cloud subscription from high above. When you want to abstract things, you can essentially draw a line like so between the control plane and the data plane. So in cloud context, that essentially means you're drawing a line between things like the console that you use to manage your subscription, essentially the access that you can get from tokens, so using CLI tools to talk to AWS, for example, and telling it to create the bucket and so on. And you're drawing a line between all of that and all the things that you deploy, right? So all the EC2 instances, all the containers, all the clusters that you have, everything like that. That's the data plane, right? That's a unique thing that pretty much every account has different things deployed. And as you can see from the slide, there's quite a one-directional relationship here. So there's an arrow going down, meaning the control plane, the hint is in the name, it controls the data plane. And it shouldn't be the other way around, right? Because that could allow an attacker who gets into one of your websites, for example, to reach out to the control plane and start telling it what to do. And that's a very dangerous situation, as we'll see later on in this training. And you should aim to avoid that. Now, it's not always really feasible. Like sometimes you need to have, let's say, a Lambda function that can reach out to the control plane and tell it, for example, hey, I need to create a bucket and move some data into that bucket. Please, dear control plane, create a bucket for me. And that's fine, as long as you really constrict what that Lambda function can do. Right, so not giving it full access, but only giving it access to S3 and for very specific resources would make a lot more sense than just giving it full access. Essentially, what I'm trying to say is you should keep this relationship one-directional as much as you can. We're going to see instances where that was not really followed and the security conditions were quite relaxed, and that's going to essentially allow us to pivot through the control plane and compromise other resources and deployments as well. So yeah, we should always try to keep those two planes separate as much as possible. Yeah, so as I was saying, the control plane mainly is the management interface. So essentially the website you log into through AWS and so on, or the command line interface that you have. And data plane is essentially very unique per customer, per account, because that's all the websites, all the Lambda functions, all the buckets and so on that you have. So from the attacker perspective, which is more interesting, the data plane or the control plane? And the answer is, well, it kind of depends. It depends, because depends on what you're trying to do. If you'd like to, if you know that your victim, your target, is running an application that's dealing with credit cards, like they're running like an e-commerce solution, and there's a payment gateway that they have, you can be certain that there's going to be some sensitive information somewhere in the storage, probably related to credit card numbers. So ideally, if you wanted to go through the data plane, you would attack the application itself and try to pivot towards the database. So that is unique attack surface, again, depending on what is deployed and is it vulnerable, is it custom made, what can we do? Versus the control plane, which is essentially unified, right? That's mainly the login credentials to a cloud console. That's pretty much what it all boils down to. And there's no success isn't guaranteed, right? Even if you manage to compromise some control plane credentials, there's no guarantee that those credentials can talk to that particular database. Right? On the other hand, if you go through the data plane and you hack the application that talks to the sensitive database, then by definition, it's going to have access to it. So it really depends on what you're trying to do. And the attack surface is really, really different. And even though the data plane is much more unique, the control plane actually gets a fair share of compromise, as we'll see in a second. Even though it's quite simple and it's quite low tech in a sense, but it still happens quite a lot. Okay, so both of those planes are essentially connected through the cloud APIs. So the entire cloud is essentially one giant API because it's quite young. We have learned, we as a community of developers have acquired a lot of knowledge since the early days of computing. And the model of separating things through an API is quite popular because it makes a lot of sense to decouple things. So the entire cloud is essentially just one huge API, and you have different front ends that talk to the same API. You've got different front ends that pull the same levers, but from different places. So you can imagine the web management console that you log into with your browser as a front end for a cloud API, and it talks to the same backend as the AWS command line tool you would be using from the terminal. So it's all just different front ends. They're not always 100% equal. For example, there are things that you can only set through the terminal. To give you an example, and I hope this hasn't changed recently, but to give you an example would be with AWS. With, for example, S3 buckets, there is an option that you can enable, which is called MFA delete. So if you want to be removing things from S3 buckets, if you want to be removing data, you need to punch in a one-time code. But you can't enable that through the web browser. You have to enable that through the terminal, even though both the website and the terminal tools talk to the same backend. They're not always 100% equal. We will mainly be dealing with the command line utilities, as you do. We'll also take a look at the console. In a couple of the attacks, it's going to be really instrumental. But we're not going to be doing much coding. So the SDKs, or software development kits, essentially allowing you to do programmatically things in the cloud, it's not going to be too interesting to us. We're going to do one exercise. We're going to be going through source code and trying to fish out some interesting information based on the SDKs used. So we're going to briefly look into SDKs, but again, this isn't a coding training, so we're not going to be looking into that too much. We're going to stick with the terminal, utilities, and the web console. Yeah, so as I mentioned, essentially all the cloud providers have this huge API that the front ends just connect to. It's all heavily documented. So like if you really wanted to, you could just be using curl to spin up an EC2 instance and use curl to do something else in your cloud environment. Technically speaking, you could do that. I don't think you should. It's really annoying. Again, the APIs are not meant to be consumed that way, but it is definitely possible. There's a lot of documentation you can look into, like a lot. Again, this probably would interest you if you are a security researcher trying to find a hidden endpoint or an undocumented feature in one of the APIs. This would be a gold mine, but extremely time-consuming and without guaranteed results. But nevertheless, everything is publicly documented. There's no mysticism involved. It's all very publicly documented. But we will mainly be using the terminal utilities, the command line tools, and that goes for all the big three cloud providers. So for AWS, there is a command utility called AWS. Who would have guessed? And we'll be using that a lot. I'll be showing you how to configure the command to essentially use your credentials. I'm essentially showcasing a couple of the popular commands here. This is probably one of the most popular commands with when you're kind of poking around. This is kind of like the who am I of AWS. Right, essentially that makes sure that you have set up your credentials properly, and it gives you an idea of what kind of account, what kind of access you might have. You don't have to worry about these too much for now. I'll always be reminding you when time comes when we're going to be using this tool, what kind of commands we want to be running. This is just to get a brief look at some of the most popular commands here. You don't have to memorize anything. Just getting a taste for what we're going to be doing. Same thing with GCP. We will be using the gcloud command to interact with our GCP environments. And finally, Azure as well. Azure, I quite like Azure because it's quite short. It's very succinct. The commands that they have are quite short. Like you don't have to do like Microsoft Azure. You literally just say AZ. So I quite like that because I like short commands. But yeah, we're going to be looking into that as well. Okay, so let's now take a look at the metadata API. So the metadata API, why even talk about this? Well, we're going to be mainly talking about metadata APIs because they historically have been the target of many attacks, and there definitely is attack surface to explore. So that's why we're going to be talking about metadata APIs. But I would like to also say that they are quite useful. So they're not wrong. It's just that historically there has been a lack of security features, should we say. But metadata APIs are very useful for just having things in cloud. Yeah, it's a very good utility, but there's a lot of attack surface attached to it as well. I should, however, say things have gotten much better over the past years. So let's take a closer look. So what is the metadata API? So it essentially is a service that your resources in cloud can talk to, and the information that those resources can get back, it's kind of like an introspection query, essentially. If you've got an EC2 instance, or if you've got two side-by-side EC2 instances in AWS, and you query this metadata API, you can query information like, what is the region I am deployed in? Or what are the security groups attached to me? Or what is my public IPv4 address, for example? So an EC2 instance can use the metadata APIs to learn about itself, because a lot of that information is not always accessible through just Linux system commands. Sometimes there's abstraction kind of hidden away in the depths of AWS. That's why metadata APIs are so interesting and so very useful, because the actual server, the actual VM, can learn about itself. From a technical perspective, the metadata APIs are just a HTTP based API. I wouldn't call it a REST API. In some cases, it's very simple. It's very simple. And broadly speaking, you can reach it at this IP address. Now, this IP address looks a little bit weird. If you were to Google this IP address, you would find that it's what's called a link local address, essentially meaning that it's not routable. Right? So if you were to punch that into your browser, it probably wouldn't take you anywhere. So it's very sensitive to the location you query it from. Right? That's why if you have two EC2 instances and they both query this IP address, they're both going to get different results, right? Because it is very, very sensitive to where you are querying it from. So broadly speaking, you can't query this over the internet. This is generally something that happens internally. And historically speaking, there have been some security issues with metadata APIs that have been resolved over time, for the most part, really. But it is still worth talking about because, especially in the case of AWS, there are still some things that could be done better. So let's take a closer look. So AWS has two versions of this metadata API running. If you look at the documentation of it, they've got a page, they've got a document comparing the two versions. And to oversimplifying, but they're virtually the same. The biggest difference is that version 1 has less security features than version 2. Again, I'm oversimplifying here, but that is the biggest difference, really. The new version essentially has this, from a developer perspective, annoying workflow that you need to follow. Right, so if you want to talk to the metadata APIs, you first have to acquire like a session token. So you first have to ask for this token, and then you need to essentially include the token with every subsequent request. Otherwise, the service will not talk to you. So the older version, version 1, does not require you to do any of this. So this is the main security feature that is new. And we will see why this is so crucial in some of the following exercises, where we're going to be doing things like SSRF attacks and seeing how we can leverage those attacks to essentially overcome some of those security features. Okay, so to give you like a more concrete example of what the metadata APIs can do, essentially, if you just query this URL from within your EC2 instance, for example, you can reach out to some of the common endpoints, like asking what your host name is, asking what your public IPv4 address is, what about your security groups, which is kind of like a firewall. Yeah, again, simplifying. What is the region of deployment? What is the data center that you find yourself in? And so on. The most interesting bit, however, is the last row right here. And that's the security credentials part of things. That is something that can contain a lot of sensitive information. Because when I was talking, if you remember, when I was talking about the control plane and data plane, I was saying, you shouldn't have things in data plane reach out to the control plane. That's a bad thing to do, but sometimes it is necessary. And this is how it happens. Essentially, your EC2 instance, which is the data plane, can talk to the metadata APIs, and it can fetch some interesting credentials from the APIs themselves. And it can then use those credentials to talk to the control plane and tell it what to do. So that's why these metadata APIs are so interesting to attackers, right? Because if there's an API that I can query and it will just give me credentials, then as an attacker, that is something I'm very, very interested in. So that is also something we'll be looking at in the future. Okay, moving on from AWS to Azure. Azure essentially being the I don't want to say younger brother, but Azure has not been around for as long as AWS, and as such, they have learned from some of the mistakes that GCP and AWS have made. So essentially, their metadata APIs has a required HTTP header called metadata, and it has to be equal to this value. If you do not have that in your request, the API will not talk to you, right? So you can't use something like SSRF to essentially talk to the Azure metadata APIs, as we'll see in a second. So this is a really good security feature. It's possibly not as good as the one that AWS have developed, but even so, this is very effective to essentially guard against things like SSRF attacks. Yeah, we'll talk about SSRF. We'll do some labs on it as well. But the takeaway from this is Azure has baked in security features to everything regarding metadata APIs, and they are pretty good. It is, from a hacker perspective, the metadata API that Azure has is not as friendly, I would say, as the AWS one. The AWS one is quite nice in the sense that if you do not construct your query fully, it will kind of give you some hints as into like what you can actually do. With Azure, that's not always the case. And immediately you get things in the query string, like the API version, and so on. With certain things like the tokens, OAuth tokens assigned to some resources, you might even need to specify extra parameters in your query string, right? So here you have a parameter called resource. It gets complicated. Essentially, this is not meant for hackers. We're going to be in this scenario quite a lot, like using a bit of functionality that is not meant for hackers to be used. That is not meant to be used by hackers. So some of it is not completely intuitive and slightly annoying to be working with, but that's just by design. So that's Azure metadata APIs. As you can see, not as neat and clean as, for example, AWS. And finally, we have GCP. So GCP have had multiple versions of their APIs. As of last year, they have removed and fully deprecated all the previous versions, even though officially they said they've done it years ago, but they haven't. It only happened last year. But even then, even so, that's really good for the overall sort of health of the internet, that these sort of insecure versions are no longer available. There essentially were some versions of the API that lack some of the security tooling and some of the security features. But again, similar to what we've seen on the previous slide regarding Azure, if you want to talk to the API, you need to specify this extra header in your HTTP requests called metadata flavor, and it has to be equal to Google. If you do not have that header, the API will not want to talk to you, which again, great security feature. One thing to note is that feature was not always present, but right now it is. And a couple of common endpoints, again, going in line with the previous slides. You can reach out to the APIs and fetch a lot of interesting information from them. Mainly things like the SA token. Again, I will walk you through a case study in GCP against Shopify that uses some of this information like the outdated metadata APIs and service account tokens and so on. So I've just got this on the slide so that you've heard about it at least once before. So hopefully it's going to make a little bit more sense when we get to it. All right, so that brings us to the next slide, or sort of the next module, where we're going to be looking at the different layers of cloud. So function as a service, software as a service, and so on. And we will be looking at the attack surface. But before we get there, I think we'll do a coffee break. Again, I've been talking a lot at you, and I appreciate this is a lot of information taken already. So I think we could take a coffee break now. And when we come back, we will start looking at the attack surface, and then we're going to do some exercises. So I think we're going to leave it here for now. I'm going to put on some time on the clock here. So I'm going to put 20 minutes on the clock. I believe that's per schedule. That's a coffee break time. And I'll let you enjoy 20 minutes of silence away from my voice. And when we come back, as I said, we're going to be looking at attack surface of Lambda functions and the platform as a service and so on. So I'll leave this timer running. I always try to keep something running on my screen so that the stream hasn't frozen, that Zoom is working. It's either going to be me talking or something ticking down on screen so that the stream hasn't frozen. Okay, so with that said, I'm going to put on a 20-minute timer. We're going to take a coffee break. If you have any questions about anything, just please let us know on Teams. I can see a lot of you have already done that. So yeah, I'll talk to you we'll come back in 20 minutes and we're going to continue. So enjoy a coffee break. Hey, hello, and welcome back. I think everyone is still with us. Yeah, I appreciate it's kind of a theory heavy start to the day, but yeah, just we just needed to lay down, just make sure we're on all on the same even playing field. Just talk about some basics. I promise you we're going to get all more technical. Now, essentially discussing the attack surface of different things, and from that point onward, we're essentially going to be talking about attacking the cloud for two and a half more days. So don't worry, there's going to be a lot of hands-on sessions. We just needed to get some basic theory out of the way. Okay, so before we get to that, let's now break down all the different offerings in cloud and look at the attack surface of it all. So again, we're going to start from the bottom. I'm going to move up. So starting at the bottom, you've got the lowest level offering, really, infrastructure as a service. So essentially, someone spins up a VM for you, you get root access, you can do whatever you want on that VM. So that's probably the most similar to what you would have on premise, which means it's very flexible. You can do a lot of things with it, but also that means you have the most responsibility on your hands. So anything from picking the operating system, making sure it stays up to date, sort of low-level system tuning and setting and security related configuration, all of that lies with you, and you need to make sure everything is up to the spec. The cloud provider only really deals with the hypervisor and like the actual hardware, but they don't really help you much with the software side of things. So what is the attack surface of that? It's quite usual, really. This isn't anything special here. The one special thing is going to be the metadata API, because your EC2 instances and your Azure VMs, they need to have a way of doing some introspection. They need to be able to understand where in the world they are, how are they accessible, what are the security groups, and can this machine do anything in the control plane, for example. So that's going to be the main attack surface here, and it is very impactful. So even though it's just one bullet point, it can do a lot of damage. Yeah, that's essentially what we're going to be targeting when talking directly about infrastructure as a service offerings. Pretty much all the other issues that go with maintaining a system, from basic configuration of network services such as RDP on Windows or SSH on Linux, through just generic system things like account management, and obviously flaws in the applications that run on that particular VM. And we're not really going to be dealing with this too much. Again, this is a cloud attacking, this is as a cloud hacking training course, so we're not going to be dealing with infrastructure things too much, like just pure infrastructure. We're going to be looking at it as well, but from the cloud perspective. So we're not going to be just brute forcing an SSH login. We're going to be doing other things. But yeah, the attack surface obviously is still there, but we're not going to be addressing it too much. So moving up a notch, we're looking at container as a service. It gets a little bit more interesting here already. So containers are very popular. Mainly, I'm going to give a shout out to Docker. Docker is very sort of developer centric, and as such, it has gained incredible traction over the years. If you've seen some of the first conferences where the people from Docker would come on stage and be like, look how quickly I can spin up a machine, and they would type docker run ubuntu bash, and suddenly, within a second, they had a shell, and everyone was like, oh, that's amazing. So it is very developer centric in its roots, and that made it very, very popular in the development circles, obviously. And it kind of persisted towards sort of larger ecosystems through orchestration, things like Kubernetes as well. But it also carries its own attack surface here. So the main thing we're going to be looking at is the image registry. So the way containers work is you prepare an image that essentially, again, oversimplifying, it's just the file system of the container. That's, oversimplifying a little bit, but that's pretty much what it is. And you need to have that image uploaded somewhere where your infrastructure can pull it down from and spin it up, turn it into a real container. So obviously that is a single point of failure, essentially. If an attacker can attack that particular registry and mess with the container images, they can do a lot of damage. So depending on how you do that, depending on if you self-host container registries or if you used a managed service, so a cloud offering, for example, Amazon ECR, GCP container registry, and so on, it might make it easier for you or more difficult. Again, a managed service by definition is trying to make things easier for you, where you just get a couple of switches to flip to configure what you would like the service to do, versus if you self-host. So should an attacker get access to this registry, and I mean full access, like being able to create things, update things, delete things, I think it goes without saying that would be quite dangerous, especially if the attacker could just pull an image down, look at the image, put something in it, like a backdoor binary or an extra service, or do something malicious, pack it up and upload it back to your registry. Some orchestration services are even quite clever. And essentially when the service says, oh, look, someone uploaded a new version of the image, let me start deploying that new version immediately. And that can lead to essentially almost instantaneous execution of whatever malicious thing the attacker has implanted into your images of the container. So that is something you should be looking out for. But even just read-only access could be dangerous, and we'll be looking at this more closely later on. But even just read access could be very dangerous, right? Your container images should not contain passwords and secrets. We all know that, but the reality is often different. And even just the intellectual property of your application or the source code could be breached by an attacker gaining access. Even though read-only access, but still gaining access nevertheless to your registry, and that could pose as an issue. When it comes to things like the Docker socket, again, I'm really glossing over this. Don't worry, we're going to have a lot more detail on day 3. We're going to be talking a lot about Docker and Kubernetes. So we will revisit all of those topics, and we'll do some labs surrounding all of that. I'm just kind of giving you a quick summary and a quick glimpse to what we will be looking at and looking into. But yeah, just the security of things like Docker socket, all the Kubernetes service account tokens and how they're mounted and where you can find those. There's a lot of attack surface that comes with containers, and not just containers, but also the orchestration of those containers, like making sure that you always have 3 containers with the API service like running at any given time, and so on. So there's definitely a lot of interesting places to look at, and we will explore all of those on day 3. For now, let's take a look at platform as a service. So platform as a service can be kind of a bit mystical. Like, what is the difference between infrastructure and platform as a service? The main benefit of platform as a service is that it just gives you a really easy way, usually, to set things up. If you are a long-term developer, you've probably heard of Heroku, which pioneered a lot of this, essentially providing with a really easy way to have some space that you can deploy your code at, and just managing things for you. And that kind of carries over as well with things like AWS Beanstalk. We'll do an interesting exercise regarding Beanstalk in a minute. But yeah, essentially, platform as a service aims to make things easier for you as a developer, for example. So the attack surface is still mainly based on whatever you're doing with the service, like what kind of application are you deploying. But there also might be some platform-specific issues. Yeah, that's pretty much the gist of a lab we're going to be doing later today. So I don't want to spoil too much, but we'll definitely revisit this, I think before lunch or just after lunch. So for now, let's take a look at function as a service. So function as a service offerings are, there's a sort of a dreaded word associated with function as a service deployments. And that word is serverless. So serverless is a great business term. It's a great buzzword, and it really annoys me because if you tell that to a person who doesn't understand how things are, they might think that it's somehow magically making things run without servers, which is not true. I mean, there's always a server. What the word truly means is that you do not get to manage that server. There's still a server, but you can't SSH into the server, or you can't influence the settings of that particular machine. You're just running code on it. So that's what serverless means. It doesn't mean that there's some kind of black magic and things just run on their own. It just means that the server is fully in control of, let's say, AWS, and you don't get a say about the particular server. So a couple of examples of FaaS deployments, things like AWS Lambda functions. You've got Azure functions, GCP Cloud functions, kind of boring names. I really like Lambda. So that's a cool name. That's a cool name for a product. Just calling it functions is kind of boring. But you can, so all of these are cloud native offerings, but you can also run something similar on premise if you'd like to. Do that through something called Apache OpenWhisk, for example. It does mimic a lot of the features that you get in cloud. However, the huge benefit of this is that because cloud providers are, everything in their environments is quite centralized. It's all easy to integrate. All the services can be integrated with one another fairly easily. So you can have a Lambda function, not just running some Python code, but you can have the Lambda function like a little helper script or a helper tool in your environment, like doing things to resources and moving data around and so on. So that is the huge benefit of function as a service deployments in cloud, where you can really use this to control your entire environment to a very fine degree, which isn't really something you can do on premise. But nevertheless, you can, to some extent, leverage this on premise as well, just not the sort of deep integration that comes with sort of a vendor lock-in, if you'd like. So that is, it's a very interesting offering. I should, however, say that there might be a lot of extra attack surface that isn't immediately obvious to you. So for us, on the left-hand side here, essentially just accessing a cloud service provider environment, we might be able to trigger some of those AWS Lambda functions. For example, if they're mapped to work as an API, right? That is a very common use case for Lambda functions. You can have like an API, and you determine that it would be wasteful. It would be too costly to have a server running 24/7 because that API doesn't get much traffic. Right? So the usage is very light. So instead of running a server, you can split the API endpoints to different Lambda functions and essentially map those Lambda functions through something called API Gateway to that particular API. And suddenly you have an option of providing an API to people, but not running a server, right? You just write the code and you just glue it to a particular endpoint. So that is one way you can expose a Lambda function to the outside world, but it's not the only one. As I've mentioned, the function as a service deployments are quite heavily integrated into the cloud environments themselves. And as such, there might be a lot of Lambda functions that you do not get to see externally. And you only really get to list them and interact with them and invoke those functions once you get in. So that's pretty much the point behind this slide, saying, you can see some things, but not all things, because some of those Lambda functions are purely internal. And only once you get in, you uncover this attack surface, essentially. There are some caveats. Obviously, function as a service deployments are quite different to just running an EC2 instance. And I should say, by the way, I'm using a lot of the AWS terminology here. This isn't AWS specific, or most of it isn't. I'm just using AWS because that's the one I know the most about. But obviously, the same thing goes for GCP Cloud Functions, Azure Functions, and so on. I tend to default to AWS terminology, so apologies for that. But if you work with AWS, you're probably fine with it. Right. So as I was saying, the function as a service deployments can help you cut down on costs, and because you don't have to manage a server. But that also has implications for us as attackers, because if you have an EC2 instance running and I get in, I can establish persistence on that particular machine, on that particular instance. And that instance might be running for a day, a week, a month, 10 years, who knows? But with Lambda functions, for example, and function as a service deployments in general, the execution time is really, really tiny. The functions typically run no longer than a couple of seconds. There's actually a hard limit on how long a Lambda function can run. So Lambda functions can run up to 15 minutes, but then it gets terminated. So if you were to somehow establish persistence, you would only get 15 minutes of use of that particular function. If you somehow manage to stall it and make it do your bidding, it's going to get terminated after 15 minutes and you're going to be back to square one. So there's the attack surface is a little bit different in terms of what kind of vulnerabilities have real impact, as opposed to something that might not be too practical to execute. Again, we will revisit this later on. We'll take a look at a top 10 of Lambda functions and function as a service deployments in general. But yeah, I just wanted to mention that because these are so ephemeral, so kind of one use, single use, disposable, temporary, whatever word you want to use, the attack methodology is a little bit different. And you need to address that if you want to be successful. Okay, and finally, the last one, software as a service offerings. So pretty much to you as an external person, that might just look like a web app, for example. Like I'm just testing Salesforce, or I'm just attacking, O365 deployment. Not very custom, not very unique. You would mainly be testing the provider's code, which isn't always interesting. So other things to look at would probably be the access control, the access controls implemented, and just essentially making more of a review as to who can access what, do they really need that level of access, and so on. Can I leverage this in any way, for example? So that's the sort of review audit methodology, but mainly you're dealing pretty much with just a web app. There are a couple of interesting points to make, however, mainly the integration of software as a service offerings. So sometimes, depending on what kind of SaaS subscription you go for, you may have your own company here. I'm just using a generic acme.com here. And for example, you want to simplify the way that people do expenses. So you subscribe to like a startup that deals with expenses, and they give you like a crazy URL, right? So for example, something crazy.cloudfront.com, or like some crazy long URL, which is kind of difficult to remember. And it also might look untrustworthy to your employees because we keep telling people to not click suspicious links, and if that looks a bit too generic, might not evoke much trust. So what you can do instead is, instead of essentially telling everyone, no, this one weird URL is fine, what you could do instead is you could create a subdomain for your company's domain name, and you can point this subdomain to whatever URL you have as like an entry point to that subscription, using DNS and using something called CNAME in DNS, which is just like a shortcut, really. That's pretty much exactly what this is. It's just a shortcut. But this is easier to remember and less likely to get phished compared to this. So it's a shorthand, but a lot of places use this. So CNAME records very often get used to essentially alias one domain to another. Now the problem is, if you stop using this service and you stop paying for whatever subscription you had, this goes away. But what we see happen quite a lot is that the integration stays. It no longer works, right? Like this shortcut is pointing to something that doesn't exist. So it's not working anymore, but the DNS record might still be in place for this subdomain, which doesn't really go anywhere anymore, but it's still trying to reach this website, which doesn't exist anymore. And that could be a security issue. Because suddenly you have something that looks trusted, but it's reaching to something that you no longer control, you no longer own. And this is very dangerous, especially when it comes to cloud, because a lot of resources in cloud have unique names, and those names are used to generate this kind of identifier. So to give you an example, what I mean would be to look at S3 buckets. So in AWS, S3 buckets are kind of like folders. So a bucket is a folder essentially, and you can put data in it. And the interesting thing is that all the folders have to have unique names. Right? So you can't create a bucket called Martin because someone else probably created a bucket called Martin before. You could maybe go for, Black Hat Asia -2022 May -10 my super cool bucket. That name probably no one else has claimed as of yet. So you could claim that for yourself, and you can, make references to that bucket in your code. But you should be careful, because if at any point you essentially say, okay, AWS is too expensive, we're going to move our data elsewhere, we're going to stop all of this, and you stop paying the bill, you unclaim that bucket, you remove it, you give it up. At that point, someone else can swoop in and they can claim a bucket with that particular name that you used to have. And if there are any old references to that bucket, then those now point at a bucket that is no longer in your control. And actually, it's in the attacker's control. So here we actually have an example of this from the Rocket Chat installer script, which essentially was looking for updates. When you were installing this piece of software, this application, it would be looking for things like updates. And it was hard-coded to reach out to a particular bucket on S3 and fetch updates from it. The problem was that Rocket Chat, at some point, they stopped using the bucket, and unfortunately, someone noticed that. Well, actually, in this case, fortunately, a security researcher noticed this, and they claimed the bucket for themselves, and they essentially did a proof of concept, whereas if you were to install Rocket Chat, it would reach out to this attacker-controlled bucket, and it would pull updates from it, So suddenly, you install Rocketjet, and suddenly you've got weird files lying around your file system, like backdoor.js, which tells you have been hacked by a bunch of frogs, which sounds ridiculous, but it's probably not something you want to see, especially on like a production server. So yeah, these things do happen. Like people claiming buckets that have hard-coded references in source code that are no longer in use. This is very dangerous. Another example of a very similar scenario would be, I don't know if any one of you are using Linux as like your main operating system. I've been doing that for years, but yeah, in Linux there's a really nice way of updating firmware, which is only a couple of years old, I would say, called LVFS, essentially Linux Vendor Firmware Service, which really easily allows you to upgrade firmware and microcode of different devices on your laptop, for example. Historically, that used to be very difficult to do from Linux, and this tends to remedy that, which is awesome. But also the developers of this had fallen victim to essentially a takeover of a resource, right? The code was checking a particular bucket. The developers behind the project gave up that bucket for whatever reason. Someone else swooped in and they've claimed the bucket for themselves. And that resulted essentially in opening your update manager. And in the update section, you suddenly have this entry saying totally not malicious. This is totally not malicious. Click here to install. Yeah, that looks pretty dodgy. Definitely not something you want to see. Again, thanks to essentially an unclaimed S3 bucket, which still had references in source code that pointed to this bucket. So this does happen quite frequently. If you'd like to know a little bit more, you can check out those further reading resources. But for us, wow, this is a very red slide. For us, that is the theory section pretty much over. And we're now going to be dealing with some labs. We're essentially going to walk you through a multi-stage attack against a fictional company called victim.cloud that we have set up just for this training. And we're essentially going to be doing some enumeration, some compromise. We're going to compromise some of their resources and assets. And we're going to see how far we can take it, essentially. So that's the theory bit over and done with. And we're now going to be dealing with the offensive section of this training. So that's going to take us a couple of days to go through. On the fourth day, we're going to switch gears and we're essentially going to be talking blue team. But for the most of this training, we're going to be talking red team. We're going to be talking attackers. We're going to be talking attacking services, exploiting services, getting a foothold, getting persistence, and so on. And this is very, very roughly the outline of what we're going to be doing. So we're going to kick this off with some enumeration, because first we need to know what we're attacking. So I'm going to show you a couple of techniques. Again, enumeration is a huge topic, and you can easily talk for the entire day just about enumeration. If you're into bug bounties, you'll know exactly what I'm talking about, because enumeration is essentially half the game in that area. But we're going to show you a couple of techniques, nothing too crazy, and then we're going to use those results we get to actually gain a foothold, get a foothold in the target environment, see what we can do with various services. We'll take a look at a bunch of cloud native services and how they can sometimes facilitate attackers. And once we get in, we're going to do some post-exploitation steps, look around, see how we can maybe escalate our permissions and so on. And we're going to wrap up the offensive section with backdooring and persistence and showing you some techniques for maintaining access to a particular cloud environment. So this is the outline for a couple of the upcoming days. It's quite big, but yeah, should be good. Should be interesting. All right, so first up, enumeration. And as I said, this is a huge topic. So essentially, we've picked out a couple of interesting points to walk you through. I'll give you some extra resources as well, but we're not going to spend an entire day on this, obviously. But yeah, it is a huge topic, and it's definitely, it might maybe deserving multiple days just on enumeration and all the cool things that you can do. But we try to pick out some interesting ones, some basic ones, some advanced ones as well, and we're going to walk you through those right now. So the methodology I will be showing you can essentially be split in two halves, right? So first up, we've got enumeration regarding assets, so non-living things. So things like domains, subdomains, buckets, like resources in cloud that you can access from the public internet, just gathering as much info as we can about a particular target of ours. And once we're happy that we have, touched on the entire environment and really found out a lot of information, we're going to start looking for the weakest links. And you may have heard this before, that the weakest link tends to be a human. It is unfortunately true. So in the second half of this module, we will be enumerating humans. We'll be enumerating living people. We'll essentially be looking for usernames, and we're going to be seeing if we can somehow acquire the passwords for any kind of username that we determine is a valid one. So again, I'll show you a couple of cloud APIs that you can leverage to perform some username enumeration, and I'll show you some techniques how attackers typically get their hands on credentials or cloud-related credentials. Okay, so let's kick this off. First up, we're going to be looking at the asset enumeration, or sometimes you may hear this being referred to as external asset mapping. So we're going to start really simple. We're going to start with DNS. And DNS might not sound like much, but it is a really good first point of call because DNS is inherently public. So if you have access to a DNS server, you can just ask it as many questions as you'd like. And it's very quick as well, so that's great. And it generally contains a lot of information. A lot of it is just required for the internet to kind of function, but it can also be used by us just to get a glimpse, get an image, get some intuition, as in what kind of services is our target using. That could come in really handy, for example, for phishing attacks, or just further enumeration really. So that's what we're going to be using DNS for. We're also going to be doing some more active, more brute forcey kind of enumeration, essentially by guessing subdomains. I'll show you some tools for that. But yeah, first up, we're going to be looking just at DNS records and what we can actually get from those records. So some commonly found records, things like MX records, essentially pointing at mail servers. Again, if that particular target is using like O365, it might be obvious from those headers. We're going to be looking at things like the name servers. Again, that can help you determine if these people are behind Cloudflare maybe, or do they pay for any extra DDoS protection, and so on. But the really interesting records are going to be the TXT records. TXT records are always interesting because you never know what you're going to find. TXT DNS records essentially are arbitrary records that you can use to present any kind of information. And we see a lot of like domain validation or proving domain ownership. Sometimes we see things that have to do with emails, like the sender privacy framework records that, again, can help us pinpoint what kind of email solutions the target of our attack might be using. Right, so to facilitate this, we'll be using a tool called Dig. Dig is a pretty old school tool, but it stood the test of time. It's a very simple tool to use. You literally just say dig and a particular host name or domain name, and it's going to dig up some DNS records for you. So this is an example here. We can see we've got a bunch of different records here. We've got the name servers here. We've got the IPv4 addresses here. We've got something pertaining to mail servers. We've got some TXT records as well. Got a lot of information here. So yeah, this is just an example. We'll be doing this in a lab in like a minute. So I'm going to gloss over this and we're going to come back to it in a second. So one thing that should be said about DNS is as great and quick to query as it is, it may not always be up to date. Right? If you think back only just a couple of slides when I was talking about the CNAME records just being left behind, essentially dangling pointers to things that no longer exist. The most critical problem with DNS is that it's not always 100% up to date. And just because there is a record for something in DNS does not mean that that resource exists. So you should always try to confirm your findings through other means as well. Some of the things we'll be looking into are going to be us trying to determine if a particular asset is hosted in a cloud environment. That can be very useful to make sure you stay in scope. We're going to be looking at things like Whois, the Whois database. We're going to be looking at a bunch of different sources of information, but that's the next lab. Right now, we're just going to be targeting DNS. But it is important to essentially acquire information from multiple sources and cross-reference everything to make sure you've not missed anything, but also you can filter out legacy things that no longer exist, for example. When it comes to subdomains, unless you can do a full zone transfer, which is very unlikely, the only way to really scan for subdomains is just guessing, essentially. So you can keep querying results or DNS records for various subdomains and just see if anything comes back. So typically you would have a list of common subdomains and just keep enumerating through that list and seeing if any of those are defined in DNS, if DNS contains any records pertaining to that one particular subdomain. So if you're attacking company.com, you could be looking for something like helpdesk.company.com, blog, wiki, HR, something like that. And a lot of those tend to exist and could host some interesting applications that could be vulnerable and essentially act as the door we're going to be walking through to get inside of the cloud environment. So yeah, full disclaimer, as I said, DNS is a great resource, but it's not always 100% reliable and accurate. So you should do your due diligence and make sure that you confirm your findings through other means as well. So when I mentioned the guessing of subdomains, you can do that, as I've mentioned, like by hand, but I think we can all agree that's going to be a little bit annoying. So as you probably know, people in InfoSec like tools. Information security people like tools a lot. We also like Python. So most of the tooling that I'll be presenting throughout this training is going to be based on Python. It is the de facto standard. Like a lot of tools are just written in Python. So I'll be showing a tool called DNSCAN, which essentially can perform some very basic DNS enumeration, help you to automatically scan some common subdomains and so on. So that's going to be a tool we're going to be looking at in a second. And that second is actually right now. Okay, so this is the first lap of this training. It's a kind of a warm-up. So don't expect anything crazy. It's mainly for us to make sure everyone's VMs are up and running and everything's okay. So let's take a look. So we're going to be looking at the DNS entries relating to one particular domain. And for that domain, we're going to be choosing victim.cloud. So throughout this training, we're going to see this a lot. This is a domain we have created for this training specifically. So, you are hereby given implied permission to go crazy. but still, be reasonable about assets on this domain and all the subdomains as well. Like everything pertaining to victim.cloud is meant as a part of this training. So don't be worried about going out of scope. As long as you stay within victim.cloud and all the subdomains, you should be good. If at any point there's any doubt or any possibility of like going out of scope, I'll let you know. There might be one case later today with buckets, but we'll get to that when we get to that. For now, let's just target victim.cloud. So right now, that's the only bit of info we have, that this is the target of our attack. Okay, so first things first, we're going to start up our VM. We did ask on Teams if how are you doing with the VM, and so far we have 9 people saying everything's working fine. If there is anyone who can't get the VM up and running, or if there's any kind of problem, please let us know. But if we don't get anything like that, then I'm just going to assume everyone's imported the VM and everything's fine. And I'm not going to bother you with watching me import the VM. And we're going to skip right to actually using it. Okay, so I'm using VirtualBox here. I'm just going to boot up the VM because, once again, I don't think anyone's facing any technical issues. I think we're all good, yeah. Okay, yeah, so I'm just going to boot up the VM. Quick note on display sizes. If you're running this on a 4K screen, you might end up with like a tiny, tiny window, which is not very readable. So a quick fix for that would be to go to View, go down to Virtual Screen 1, and scale things up and down as you please. So I'm presenting this from a full HD screen, so I'm not using a 4K screen for presenting this. But if you are, you probably want to scale up to like 200%, which would look something like this, which is a bit too big for me. But if I was on a 4K screen, I'm pretty sure that would be the ideal scaling factor. So if you're dealing with a 4K screen, be sure to check that out. But I'm not, so I'll just log in. The credentials are, the username is Pentester, as you can see. The password is also Pentester. So I think that's also mentioned in the guide. Again, I've got a lot of emails and thumbs ups coming from you, from all of you, saying you can log in. So that's great. So I'm just going to log in. I should say that yeah, if you're dealing with like a tiny window like this, usually unmaximizing and maximizing fixes things. So if the screen is not properly resizing, just try to unmaximize the window and maximize it again. That should hopefully resolve all issues. If you so the default keyboard layout, I believe, is the American English keyboard layout. If you're not happy with that, you can change it by pressing the Start key and typing in layout. And you essentially get to edit your input sources. You can see I've changed it to something I'm a little bit more comfortable with, which is the Czech keyboard layout. But you can change it to whatever you'd like. If you don't like the US English keyboard layout, feel free to change it to whatever you'd like. Okay, so that's the VM. Again, I don't see anyone posting any issues, so I'm going to assume everything's fine. That's awesome. And now let's take a look at the actual lab itself. So I'll be showing you some commands. Don't worry about like copy pasting everything I'm showing you. All the commands, every single command that I'll be doing and presenting, we've also written up for you, and we will be sharing that with you in a second. So don't worry about like not keeping up or anything like that. I will always demo all the labs, and then I'll give you some time to look into these labs yourselves, and answer any questions, or do the demo again if anyone would like to see it again. But yeah, that's pretty much going to be the layout. I'll always demo everything first, and I'll share all the commands with you and give you some time to get some hands-on exercise experience with the lab itself. Okay, yeah. So first lab, really easy. Just looking at DNS really. So let's open a terminal here, and let's see what we can do. Yeah, let's take a look. So we're going to be using a tool called Dig, as mentioned. It's a very simple tool. You literally just give it a domain name like Victim Cloud, and off it goes. Right, so it's going to give us a lot of output, possibly too much. You can see essentially all of this is just gibberish. We're not interested in. We're only interested in the actual results here. So we can cut down on a lot of that chatter with some switches like no all and answer, which cuts down on a lot of this. Yeah, it just queries the records we ask for, right? So we could be asking for example, the IPv4 records. We could be asking for the mail server records and so on. Again, doing this by hand is kind of annoying. There's a lot of typing involved. So there is one trick that you can do, but it doesn't always work. And that's to use the any keyword, which in ideal conditions will list all DNS records pertinent to this domain, but it doesn't always work. So you can see if I try to run this command with the any keyword, I just get a very short response saying, read this RFC, you're not getting anything from me. And if you do that, essentially RFC deprecates this any keyword to an extent, but this really depends on what kind of DNS server you're dealing with. For example, if we run the same thing against a website that I control, so I'm giving myself permission. Let's run it against fcbarcelona.cz. Okay, I may need to specify DNS server here. Yeah, you can see that I get a lot of output. I get a lot of results. Right, I get some things pertinent to DNSSEC. I get some name servers. I get some A records, mail server records, IPv6 records, and so on. So this any keyword still works sometimes, but not all the time. So it's good to know about. Really depends on what kind of DNS service you're dealing with. But we're dealing with Victim.Cloud, and the any keyword doesn't work for Victim.Cloud. So what we can do instead is just whip up a quick bash loop. Oh, that was quick. And essentially just loop over these record types and query all of them. So I'm going to first query TXT records, then I'm going to look into mail server records and so on. So just running this provides me a ton of output. Once again, I don't have to bother typing all this out. So I get some text records, I've got some mail server records, and so on. The TXT records are probably the most interesting ones. I can see that there are some records with MS. So maybe there's some integration with Microsoft services like O365. There's Facebook domain verification. So Victim.Cloud possibly have something to do with Facebook, like maybe they're app developers or something like that. So that's interesting. There's Google site verification header. Oh, sorry, not a header, a record. Typically used if you use something like Google Webmaster Tools, if you have your website enrolled into that program, maybe they're using something like analytics or something like that. Essentially, they had to prove ownership of their domain. So there's definitely some Google integration here with some Google services. So definitely worth taking a closer look at. There's a have I been pwned verification. Have I been pwned is a really interesting service that can help you monitor password leaks from various sources on the internet. And it looks like these Victim.Cloud people are fairly security savvy. They have some kind of integration with have I been pwned. So that's a good indication that maybe things like credential stuffing attacks might not be very effective against Victim.Cloud, because they seem to be on top of password or credential leaks. And lastly, there's a TXT record with SPF. So SPF is a sender privacy framework. It has to do with emails. It has to do with who can send emails from your domain. Ideally, you only want your mail servers to be on this whitelist. So we can see that these servers can send emails from @victim.cloud. The very last bit is interesting because it says include spfprotection.outlook.com. So this is making me think that Victim.cloud are using O365. They're using O365, Outlook.com, essentially allowing Outlook.com to send emails from @Victim.cloud. So, if I want to launch a phishing attack or if I want to target some of their supply chain, this is a good bet that it might be integrated with O365. Maybe they're integrated with Microsoft Azure. Definitely a couple of things that I'm going to be looking into later as an attacker. It's already giving me a bunch of ideas here. Okay, so that's DNS. Just looking at the basic records here. Now we can switch gears and do some more active enumeration. So what I can try and do is I can try to guess some common subdomains. So I'll switch to my, I should say, there are a lot of folders and files that you'll find on your VM. There's a tools folder. If you check out the tools folder, it has a bunch of tools that we're going to be using throughout the training. And we're going to start with DNS scan, which is just a Python script, as most InfoSec tooling is. And we're going to be running this. So I'll just pass it to Python. If you just run it like that, it's going to give you a quick help section saying, well, you need to give me a domain or a list of domains. And it's going to scan that domain. So I'll say -d for domain, Victim.cloud. And you can specify a DNS resolver to use. You can also omit that and just use your local one. But again, depending on your ISP and depending on the DNS service that you use by default, you may get different results. Maybe you're going to get rate limited. So I would recommend doing -R and doing either 11111 for the DNS service provided by Cloudflare, or maybe 88888 for DNS provided by Google, because we know those are fairly solid and give very stable results anywhere on the when you query these services from anywhere in the world. And lastly, we'd like to scan some subdomains of this domain. So I'm going to do -W, and I'm going to feed it a file full of common subdomains. So let's actually take a look at that file first. Let's do ls subdomains txt. I don't know if you can see this. Let me, do it like that. So this is a file containing a bunch of fairly common subdomains, like admin.something.something, or ads.something.something, or API.something.something, auth, and so on, or backup, and so on. So a lot of common subdomains can be found in this file. So we're going to feed this file to the Python script. The Python script is going to go through that file and try to determine if these domains exist, or subdomains exist, I should say. So I'm going to let this run. First things first, it does pretty much what we did by hand just a minute ago. And then it performs some automated scanning. First up, it doesn't find anything interesting at first, just finds the domain itself and resolves it. And then finds www.victim.cloud, which again, fairly standard. We could have thought of that ourselves. But then it does stumble upon something interesting that we haven't seen before. And that's db.victim.cloud. That subdomain we haven't seen before. The IP address also looks to be completely different, from like a completely different block. So that's interesting. Definitely something we're going to be looking into later on. But yeah, this is the first lab. As I've said, it's pretty simple, it's pretty basic. It's mainly like a warm-up exercise, really, just so we can all get up and running regarding the VM. So take a look. Also, CTF challenges can essentially ask you a couple of extra steps. In this case, this is the enumeration 1 lab. So looking at the CTFD instance here, we've got enumeration 1 task is identify various entries and try to pick out the one that has to do with the database. So yeah, I think that's fairly simple. So that's probably the one. So I'm just going to copy that from all subdomains into the subdomain which is with the database. So that's probably going to be db.victim.cloud. And if I submit this, I get, yep, that's it. So yeah, you can follow up on that. It's going to build up a nice scoreboard. We can already see some people just running away with the challenges. So that's great to see. Yeah, and we're gonna have hopefully more people joining in very soon. So that's the CTF. And also, I did say that we will be sharing all the commands that I'm using with you, and we are. So if you look at the training portal again, there's now at the very end of the menu, there's the solution enumeration 1 page now, which essentially walks you through everything that I said, all the commands that I used, what are the parameters, what do they do. You even get like a sample output of all of those commands, so you know what to expect when you run the command. And essentially, this should serve as your reference for everything. So if you've missed anything, or you're trying to catch up on a previous lab because you had a meeting or anything like that, this should be your first point of call, because it's going to have always all the commands and the output associated with those commands. Okay, we're also going to be posting a poll in a couple of minutes regarding on how you're doing with the lab. Like sometimes we can see from the CTF, but if we're going to post a poll saying how are you doing? Do you need more time, less time? Do you need help? If we're going to see like everyone's giving us a thumbs up saying we're all done, then we can cut the time short and just move on. But if that doesn't happen, then I'm just going to put on a timer, and I'm going to put on 10 minutes for the lab, and that should give you some time to get the VM up and running, and ask for any support if anything's not working correctly, and we'll try to resolve that for you. Again, it's a simple lab. It's mainly a buffer for me and my support team to try to figure out if there are any issues, any technical issues with anyone's VM. Okay, so that is it. I'm going to take a look at this lab now. I'm going to put on 10-minute clock, and I'll see you then. So good luck. Okay, hello and welcome back. So yeah, we're still troubleshooting some network issues with some of you, but I think most of us have been able to do this lab, sort of get warmed up essentially. Let's look at the scoreboard real quick. Yeah, I can see some people running away with this, but it's awesome to see so much participation. So thank you very much. Thank you very much for taking part in the CTFD instance. This is awesome to see. Yeah, over the course of a couple of days, we're going to paint like an abstract painting consisting of lines. So I'm curious what you guys are going to come up with just by submitting the flags. Should be interesting. Okay, so that was a very, very basic lab. We got a little bit of insight into victim.cloud. We found a subdomain, which is a good start, but we can definitely do a little bit more. So we're going to do a little bit more. We're going to start looking at other sources of information. We're essentially going to be performing something called OSINT, Open Source Intelligence Gathering. That means we're going to be sort of passively ingesting a lot of information about victim.cloud and try to just find as much as we can about that particular domain. So some of the some sort of gold standard sources of information could be things like search engines. So for example, Google Dorking, or looking at things like the certificate transparency logs, which are kind of a newish thing, but are very, very valuable, especially for sort of basic enumeration, basic research like this. So let's start this off with search engines. So if you've been using Google for long enough, you may remember that at a certain point, many years ago, if you were searching for an English phrase, and that phrase had the word and or in it, then Google would pop up like a little notification thing saying, hey, we understand that you're looking for the entire thing. You don't need to use logical operators. Because at that point, it used to be, it was a little bit of an art to efficiently search the internet. But obviously now with advances in natural language processing, it's become much easier to do. And Google no longer treats the word and as a logical operator. But there are still some keywords, and there are still some little tricks that you can use to refine the search results that you get from Google, and not just from Google. This works on Bing as well, and Yahoo, and so on. But yeah, we're mainly concerning ourselves with Google here. So there's a couple of major keywords here, like site colon. Essentially, you can search for results from a particular domain. So this also works on the top level of the domain. So for example, I could search for a keyword and say site colon CZ, and that's going to filter out only results from .cz, right? So only check the results. But I can also do the same thing with .com. So scratching that out and just doing .com, that's only going to give me results from domains.com. But I could also specify a full domain or a subdomain and limit the search results to that particular domain or subdomain. I can also filter by keywords that exist in that URL. You can even look at the file type of the results. So for example, I could, if I wanted to find PDFs on a particular website that I'm enumerating, I could search for site colon, the website I'm searching for, file type colon PDF. And that's just going to give me all the PDFs that are linked or live on that particular domain, which could be really interesting to do, especially when we're going to be talking about username and credential harvesting. That could be an interesting thing to do. You can also negate these results, right? So I can preface any of these keywords. I can preface them with a dash, and that will essentially flip the condition around, right? So if I would put dash file type PDF, it would find everything but PDFs, right? So you can also flip these conditions around and really refine your search results. So okay, that's been known for a very long time. It's a very useful sort of more advanced search option for Google and other search engines. How does this relate to cloud? Well, it just so happens that a lot of resources in cloud have to have unique names. Not just S3 buckets, but many other deployments need to have unique names. And that is because you typically get assigned a special URL that you can use to address that resource of yours. So sticking to an easy example here would be a bucket. So any bucket in S3 has also this unique subdomain where you have your bucket name right here, and it's yourbucketname.s3.amazonaws.com. And that essentially functions as its own subdomain. So for example, we could run this search query on Google, right? You can say, please filter results from any subdomain of s3amazonaws.com and look for a particular keyword like example.com or victim.cloud or password, something like that. And it sounds silly and it sounds low tech and sounds easy, and maybe you wouldn't expect much, but these screenshots have been taken a while ago, so I'm sure these numbers have increased. But just looking at all the different buckets which are indexed by Google, we're talking on the order of millions of results here. Like that's a lot of content in publicly accessible S3 buckets. Same thing can be also repeated for Azure storage. So looking for things at core.windows.net, or Azure resources to be more precise. Also talking on the orders of millions of results here. So there's a lot of content that is indexed by Google, and that's only scratching the surface really. So all of this is searchable through Google, and we can leverage that to essentially do further enumeration. So here are a couple of interesting things to search for. For example, right here in the first one, we're searching through S3 buckets on Google, or potential on Google, and we're looking for files that have the .sql extension. So those files could be installation scripts, like you're setting up a WordPress website, and for whatever reason it's not doing things automatically, and you get an SQL file that you need to run against your database. Or it could be like a backup generated from the database itself. Either way, it could be pretty interesting. Or we can look for text files, or we can look for TXT files that contain this word, password. So that could be very interesting. Or we could be looking for Swagger files. If you deal with APIs, you probably know what that is. We could be looking for all sorts of interesting things on Google. Again, if it gets to the point where Google has had time to index this potentially sensitive content, there's a good chance you're not the first person seeing it. But regardless, it's worth a try. One search doesn't hurt. There's very little effort from our side as the attackers, and the potential for learning new information is quite high. Okay, now let's take a look at CT logs, or certificate transparency logs. So certificate transparency is an interesting concept that essentially means that every single SSL or TLS certificate issued has to be there has to be a note on like a global log for the entire internet, on a global ledger. There needs to be a record of who issued this certificate. That essentially protects the internet against certificate authorities that go rogue, and maybe because they're being pressured by a government, or maybe for just their own personal gain, they might start issuing certificates for sort of unsolicited certificates for things like Facebook.com, for example. So if you have a valid certificate for Facebook.com, you could start performing man-in-the-middle attacks, and everything would look completely fine because you have a valid certificate that you can show users. Normally, TLS would protect against a man-in-the-middle attack like that. But if you can get your hands on a certificate, a valid certificate, then your interception activities will be not impossible to detect, but a lot less likely to be noticed. And this has historically happened a couple of times. So that's why we have a global ledger where every single certificate issued needs to be on. And your browser can then check those logs when you're connecting to, let's say, Facebook, to make sure that that certificate that you're being served is actually on that list. So what this does is it would provide, let's say, Facebook with facilities to notice that a rogue certificate authority has been issuing certificates for Facebook.com when no one asked them to, and that looks a bit strange. So you can launch an investigation into that. So it's a really good feature that we have on the internet for privacy and maintaining privacy and security online. So yeah, certificate transparency logs are awesome, are really good. But they can also be used for, I don't want to say nefarious purposes, but they can definitely be used to enumerate things, right? So we can search those logs ourselves, as we're going to be doing in a second, to try to find certificates issued to particular domain names or subdomains that might interest us. So there are many different search engines that allow you to search these logs. We're going to be looking at the crt.sh, but it's not been known to be the most stable website. So sometimes you might need to use something else like Census or Shodan or just any other real engine. They all search pretty much the same data, so it doesn't matter which one you use. So you can choose whichever you like the most. You can even use Shodan. If you've never heard of Shodan, I think their motto is like it's very like Google but for IoT. So Shodan is a really interesting project. I recommend you check it out if you've never heard of it. It essentially allows you to search devices on the internet, not necessarily just websites, but smart devices connected to the internet, like an intelligent toaster that sends you an email when your toast is done toasting, like crazy things like that somehow find their way on the internet. Shodan is a great search tool for that, but it can also be used to look into DNS related things, and also be used to search through certificate transparency logs. All right, so that's what we're going to be doing right now. We're going to be looking at a couple of sources of information we can leverage to essentially understand a little bit more about victim.cloud. So I'll switch back to my VM here, open Firefox, and let's have a look. So let's start looking around. So first things first, let's look at the crt.sh website. Okay, so it's working today. There's always like a 50-50 chance when I'm presenting this that it's not going to load, but it seems okay right now. Okay, so as you can see, it's a very simple website, and you can query for various aspects of a certificate. I'm just going to query for a domain name, and I'm going to put in victim.cloud. And when I run this search, it's essentially going to come up with all certificates issued to victim.cloud or any of their subdomains. All right, so that's the great thing about this. We can very easily discover new subdomains. So we can see that actually yesterday, there was a new certificate issued to victim.cloud. So that's not very interesting because, well, that's just the domain. But if I scroll down here, I can already see some interesting subdomains like AWS Lambda.victim.cloud, Azure Function.victim.cloud, and a couple more. So there's a vOffice.victim.cloud, already finding a bunch of subdomains here. So that's great. Already getting a lot of value from this, from just a simple search. We're getting to know that there are some subdomains that we haven't seen before. And you can do this in the browser and take notes, for example. But in a true sort of, I don't want to say, I don't want to use the word hacker, but yeah, in like a hacker fashion, maybe that's not for us. Like, we don't like doing things manually, right? So you can also query this website from the terminal and essentially just parse the output here. There's one quick trick you can do, because obviously this is fairly readable. It's a table. This is human readable, but we can also tell crtl.sh to give us JSON. So that makes it a lot more machine readable. So this is the same results still, but it's now a JSON document. So it looks like this. You can kind of visualize it a little bit more like so. And this is much easier to process in a script, for example. So I'm going to copy this URL here, and I'm going to process it in a terminal and essentially fish out interesting information from the website. Okay, so what I've done just here is I've queried this page that I've opened in my browser. Again, this is just this page that we've been looking at, but we requested it to be presented as a JSON file, like so. And we're just going through this JSON file, and we're picking out certain elements. So we're looking at the common name of all of those certificates, which contains the subdomain or the domain that that certificate has been issued to. And I'm also saving this locally, for future work. So AWS Lambda Ludwig Network Cloud, we have seen that one already. Azure Function, we have seen that one as well. There's one called Incognito, which is interesting. We haven't seen that one before. So domain itself and the office. Cool. So already getting a lot of value. Notice that we don't see the db.Ludwig Network Cloud here. Maybe it's not a website, so there was no certificate ever issued for it. That could be one explanation, or maybe it just doesn't use HTTPS, so they have no need for a certificate for that domain. Who knows? But yeah, getting a lot of value here. So we can also get sort of an idea of where these things are hosted. Well, in this case, these subdomains are quite suggestive. You might get some intuition about AWS Lambda Ludwig Network Cloud probably being hosted in AWS, and vice versa with Azure Function. But we can try to determine this from a little bit more precisely, and we can essentially query the same information, but actually look at the organization that issued that particular certificate. So if I run that command now, you can see I'm looking for the domain and the issuer's name. I can see that the AWS Lambda certificate has been issued by Amazon. So again, that confirms the hypothesis that this is an asset hosted in AWS. With Azure here, we have a certificate issued by DigiCert, so doesn't tell us that much. Incognito once again has a certificate issued by AWS, so that's interesting. And you can essentially continue your investigation like so. One more thing we could try to do is to use the Whois database. So the Whois database is quite interesting. You can essentially look up domain names here. So I can look up, for example, my own website, my own domain. And if I do that, you'll see I get a bunch of results, mainly my full name here, and the people that are responsible for running some of the infrastructure that I'm using, and like full addresses and so on. Thanks to GDPR in Europe, we no longer have like a full address here. This used to be a crazy thing that leaked a lot of information. Like any Czech domain you would look up had your full name, your full address, your phone number, your email address, and all of that had to be like manually verified as well. So it used to leak a lot of information, but luckily, thanks to GDPR, we now get to not disclose so much information about the owner of a domain. But this really depends on what kind of domain you're looking up. I mean, if we do the same thing to, let's say, AWS Lambda, the victim of cloud, we get absolutely nothing. It just says no data found, and it just tells you that, you know, you shouldn't be abusing the service and that there's no data. Right, so it varies domain from domain. Not all top-level domains provide much information here, but it's always worth a look. Like, it's one query, you can get a lot of info out of it that way. What it is pretty good for is if you try to look up not a domain name, but an IP address instead, it can essentially look into the allocations of IP address blocks and see what that particular IP address belongs to, which block, and who owns that block. All right, so to make this a little bit more clear, when we looked up AWS Lambda victim of cloud in Whois, it gave us nothing. However, if I first resolve this domain name into an IP address, and I ran Whois against this IP address here, I now get completely different results. Right? I actually get results about this entire range of IP addresses, and apparently they're assigned to Amazon, AWS, Amazon EC2. Yeah, a lot of references to AWS and Amazon here. So I think it's safe to assume that this domain name is really hosted in AWS. We're getting a lot of confirmation on that. You could also do this automatically rather than me doing it by hand. So let's run this quick for loop I have here. So I'm just enumerating all the different subdomains that we have discovered and resolving them to IP addresses and then looking those up through Whois. All right. So again, it's just a quick, dirty one-liner here, but you can see I'm getting a lot of information out of it. If I look at the AWS Lambda subdomain, I resolve it, I look it up in Whois, I can see references to Amazon and AWS. So good chance this is hosted in AWS. If I do the same thing for Azure function, I'm getting references to Microsoft. So again, good indication that this is hosted in Azure. With victim of cloud, it says GitHub, which you might find strange. But actually, GitHub has GitHub pages where you can essentially host things hosted on GitHub. So that kind of makes sense. And finally, we have the vOffice app here. And again, it has references to AWS. So probably also hosted in AWS. Yeah, so you can get a lot of value out of it this way. You can also use other search engines. For example, let's look at security trails. Again, I'm not advertising this because some of it is a paid service, but even the free section offers quite interesting, can offer quite interesting results here. So I'm just going to search for victim of cloud. It's a little bit bigger so we can easily read it. Unless I'm not going to give them any money, so I may not get to see the full results here, but and the historical data and things like that. But if I look at the subdomains section here, the good people of Security Trails have done some enumeration themselves regarding the victim of cloud domain, and they have came up with 8 different subdomains. So some of those, like Azure Function, vOffice, AWS Lambda, we have seen before through certificate transparency. db.victim of cloud, we have manually brute forced. That's the way we found out about it, but somehow Security Trails also know about it. And there are even some subdomains that we haven't even seen yet. Web App 1 and Web App 2. So I just wanted to essentially show you that, the more sources of information you have, the better results you're going to get, and the less of a chance that you're going to miss something interesting. It's like we're already, like, for one quick query, we're already getting even more value here. So yeah, it's a cool project, Security Trails. There are a lot more projects like this that essentially index a lot of things on the internet and allow you to search through it. A good resource for automating a lot of this would be the OWASP Amass. Let's take a look at that real quick. So the OWASP Amass is essentially a piece of software that that's got a pretty cool 3D spinning logo, first of all. So clearly it's a cool tool. But mainly it is capable of gathering information from all of these places. That's a lot. So from certificate transparency logs through DNS brute forcing and sweeping and zone walking, through WHOIS databases and various APIs from, for example, Security Trails, but also VirusTotal and Twitter and Cloudflare and many places. It can help gather information all in one place, and it can do all this pretty much automatically for you and help you aggregate all of this. So this is a super useful tool, OWASP Amass. We're not using it in this lab because it's a bit of an overkill, but you could definitely use this for your own sort of enumeration adventures, or just run it against your own company and see what comes out. So I just wanted to give a quick shout out to OWASP Amass, and if nothing else, this could serve as a good pointer to all sorts of interesting sources of information. Okay, so that's the second lab. Again, quite manual, but I just wanted to showcase some interesting projects. So let me put 10 minutes on the clock again. Again, we've already shared all the commands and all the websites with you, so you can check out the commands on the training portal. And with that said, I think actually we're approaching the lunch break. So yeah, I think we're approaching the lunch break. So after 10 minutes, we're due to break for lunch. So let's merge the two. And lunch break is supposed to be 90 minutes, I believe. So 90 minutes plus 10, that puts us on 100 minutes. So I'm going to put 100 minutes on the clock, and we're going to take a break for lunch, plus the 10 minutes for the lab. If you've got any questions in the meantime, feel free to post on Teams. But yeah, I think we're going to take a little break and hopefully get something to eat. So with all of that said, I'm just going to put on the timer, and I will see you after lunch. So yeah, have a great break, everyone, and see you in a minute.